So in the previous video, I looked at f of x equals root x, and we looked for the derivative, which I indicate by f prime of x. Although actually I didn't really find f prime of x. What I did was I found what f prime was at for a particular value, and the one that I looked at was 4. At the end of the video, I said that it would probably be a lot more useful if instead of finding just the derivative at a single point, I could find an equation for the derivative, because then I could actually look at and do stuff with it and analyze what's happening with root x based on its derivative. So that's what this video is about, is figuring out how do we get to an equation for f prime of x instead of just finding the derivative at a specific point, because this would be way more useful. To do this, I'm going to look at a secant line. So a secant line. I'm going to draw some pictures, and my pictures will be of root x, but we could apply the same thing to any old function. So a secant line is, if you look back at the last, well, hold on, I'll draw it. So I drew a secant line here, right? So what I want to do is, I've got my little triangle that I can draw. This would be delta f. This would be delta x. What I'm looking at on my secant line, I'm looking at the slope of it. So it's delta f over delta x. And I can write that as f of x minus f of, f of a all over x minus a. If this was the x value that I was looking at and this was an a value, right? Kind of talked about that a little bit in the previous video. So, my derivative is a tangent line, so I'm going to come down and draw 2 additional pictures. So, I'm going to show 2 different alternative options for definition of a derivative at a given point. So, I'm going to do 2. I'm going to do one that is a point and one that is an equation, and you'll see what I mean in a moment. So, the first one, I'm going to call this x and this a, which, if I were to go straight up, would give me these 2 points. This would be f of a. This would be f of x. I can draw my little triangle, and I could look at my difference quotient. Now, this is pretty similar to, actually this is pretty identical to the one that I talked about in the last video, but I'm going to do it really quickly. The derivative for this particular spot would be the limit as x approaches a of f of x minus f of a all over x minus a. Notice in the top I'm subtracting these 2. In the bottom I'm subtracting these 2. And what I'm doing is I'm letting this guy go close to there. The only difference between this and the previous video is that this was a given point, and I was letting this get close to the point. So all I'm doing, it looks almost exactly the same as the previous one, except for instead of having a 4, I'm going to let that be an x. And you'll see how this comes together, and I'm letting this thing shrink into it. So the other option is at a point, and this one I think is actually a little bit easier to work with for polynomials, and I'll show you an example. So I'm going to let this first point be a, and then I'm going to let this distance be h. And instead of making sorry, instead of in the previous one where I let x slide into a, I'm going to let h slide to 0. So a is going to be over here, and h is going to be the distance between a and this point. And instead of assigning a new variable to this new point, I'm just going to look at it and say, well, this length is a, this length is h, so this coordinate out here is going to be a plus the h. So that makes this a plus h. And then I do the same thing. I go up to here, I go up to here directly above, I go out to here. This is f of a. And then I go over to here, and this is f of a plus h. Now, the limit definition that I get here when I draw this little triangle is the limit as h approaches. Remember, I want to make the h here shrink down so that a and a plus h become the same thing. Shrink this triangle, make that point the same as that point, get the value of the slope. So the limit as h approaches 0 of, where is it? Ba-dum. Oh, sorry, yeah, that's what I was going at. As h approaches 0 of f of a plus h minus f of a all over h. Notice that h is that distance right there. I could think about it as just h, or I could think about it as a plus h minus a. H's go away, give me the h. Alright, so I'm going to go ahead and use this one. This is a derivative at a point. It's similar to our first example on the previous video. So this is f prime of a. And then this one over on the left, do I have any space, is f prime of x. And I'll show you an example where I do one of those in a moment. So, what I'm going to do is use that first definition. So, let me go back to it. Oops. I'm going to use this blue definition right here to find the derivative of this thing at 3. So, I'm looking at the limit. Actually, I'm looking for f prime of 3, and that's equal to the limit as h approaches 0, fraction bar. I get an h in the bottom. And then I have f of my value, 3, plus h minus f of 3. You should see, I'll flip back, that's the same form. My a value is the 3. And then I've got the h, and then minus the f of a. So if I flip forward, you can see that that a shows up here, and the h shows up here and here. A here and here, h here and here. All it is a difference quotient. It is slope. So when I do this, I'm going to plug in. So it's equal to the limit as h approaches 0. And remember, I have to keep my limit notation there all the time. So it is 2 times. So now I'm just going to plug these values, or this value in for x here, and then subtract this value in for x as well. So as I do that, I get 2 times 3 plus h squared plus 10 times 3 plus h. That is this part right here. Maybe I'll change colors. So the next part is going to be this. So minus f of 3. So I'm going to go minus, I'm going to put a little bracket, and then I'm going to go 2 times 3 squared plus 10 times 3. And then that's all going to be over top of h. You may be like, oh my god, but trust me, it will work out very nicely. So this is equal to the limit as h approaches 0 of 2 open parentheses. I need to square that out. When I square it out, I get 9 plus, don't forget your middle term, 6h plus h squared plus 10 times 3 plus 10h, and then minus 2 times 9 is 18, and then minus 30. And you'll see why I left those there as we go through. And I forgot a set of parentheses right there, all over h. Maybe you already see some things that are about to cancel. Remember, I'm finding f prime of 3. So, this is equal to the limit as h approaches 0 of 2 times 9 is 18 plus 12h plus some distributing, that was the 12h, plus 2h squared, 30, 10h, blah blah blah. So plus 30 plus 10h minus 18 minus 30, all over h. So what I want you to notice is that I got an 18 here, that's positive, and a minus 18. So they cancel. Similarly, I've got a plus 30 and a minus 30. They go away. If I've done my work right, then things like this should happen. I'm going to collect my terms. You should see I had a 12h and a 10h. They made 22. 2h squared came with 2h squared. And I got this guy on the bottom. So you should see that I have some h's that cancel. This guy is going to cancel with this and one of these. So that's now going to just be a power of 1. So my almost last line is the limit as h approaches 0 of 22 plus 2h. Now, notice, all along I could not plug in h equal to 0 because I had that h in the bottom. Now, just like we've talked about with limits, I've gotten rid of that issue because I've canceled it out. So now I can plug in h equal to 0. So you should see that my final answer is equal to 22. So what that represents is the slope, of whatever this function is at x equal to 3. So I'm going to go over here, and we'll come back to that in a moment. One of my other equations looks very similar. Go back to here. If you remember this thing right here, it was actually very similar to the one that we either talked about in class or the one in the previous video. So I'm going to have another very similar definition of a derivative for any given point that's similar to that h. I'm going to write it out. Oh, sorry, I didn't realize I wasn't paused there. Anyway, you now see that, and you watch me write it and didn't say anything. Anyway, so this is super similar to that previous definition, and you should see that it's another difference quotient. I could draw a picture. So if I had a function, this would be my x value, this would be my x plus h value. My triangle would look like this, and then you can see that I would subtract. This would be f of x plus h right here. This would be f of x, and I get that same difference quotient. Okay, so I'm going to do this with that same function from before that we did over here, but instead of finding it f of 3, or f prime of 3, I'm going to find the actual equation like I've been talking about all along. So, f prime of x is equal to